Hello, eighth grade. This is Mr. Dreisbach, and here is your next set of notes for physical properties. This is for pages 12, 13, and 14 in your notes. Only 3 pages, but a lot of important ideas. So please listen closely and write down everything you see and write down questions when you have questions. So here we are on page 12. So at this point, we're going to be talking about states of matter and changes of state. But before we do so, I want to sort of back up a little bit and actually get a little less complicated. From here on out, we're gonna call atoms and molecules and chemicals, because we know atoms come together and they make molecules. In general, we can call those chemicals. But from here on out, we're just going to call all those things just particles, right? So water has water molecules. We'll just call them water particles. This is a metal clip. I don't know exactly what metal is in here. There's probably a couple different types of metals. I'll just say there are different particles in here, right? Or plastic has different plastic chemicals. I'm not exactly sure which atoms are in those chemicals in plastic. I have an idea. But in general, at this point, we'll just say things are made of particles. And to do that, we kind of have some sort of 4 big rules to think about as we're heading into that. So the first, and some of this is review. So like the first one is that all substances are made of particles. This is like the earlier idea about atoms, right? That all material is made out of, all substances are made out of atoms. And we can say the same for particles, right? All stuff is made of super small stuff. We'll just generally call those particles. And that all the particles in a substance are the same for that substance. We can work under that assumption. We know that like this is a sticky note, and I don't know exactly what chemicals are in here, but I could say that whatever particles are in here in this sticky note, I'm going to guess are probably the same as this sticky note. The 2 substances are the same, so I can assume that their particles are the same. And you'll see when we look at different types of substances, we can think of things that way. The third sort of rule, and this is kind of getting into a next sort of level of how those things are moving around. Particles in general have some level of attraction, not just ionic or covalent bonds, but they're also, when particles are near each other, there are levels of attraction that they want to be near each other depending on how much energy they have. And we'll see how that plays a part in the states of matter in a sec. And the fourth big idea about particles, and this is a new one, this is kind of a cool idea, is that those particles, in other words, those atoms, molecules, the chemicals themselves, those particles are always in motion. They're always moving around. And in fact, you'll see in a little bit, we're going to be looking at this lab activity. This represents the particles in a certain type of substance. And notice that though they might not moving a lot, they're moving around a bit. You can kind of see that they're moving around there. So we're going to keep that in mind as we go through. Okay, so that's the keep those 4 ideas. With those ideas, we're going to look at and think about all the different states of matter. This is a pretty important note page, and we're going to start with a solid. And kind of like we've seen over here, imagine we have a solid, maybe it's ice, and the particles are in there, and it's a solid. And in general, the energy level in that, the energy of the particle in general is pretty low. And because they're low, the energy is low, those atoms, particles, are pretty packed together pretty tightly. They're kind of squished together there. They're pretty tightly packed, generally speaking. Because they're tightly packed, it's important to note how they are moving, the atoms, the particles, relative to each other and relative to the group. And if we look at it here, they're not moving around each other and they're not leaving the group. In a solid, they do not move around each other. The particles don't move around each other very much, and they don't leave the group. We can say in here that they're not moving around each other and they're not leaving the group. They're staying in this crystal, this structure, this solid structure in a solid. Because of that, because of the nature of the particles, we can say, let me move this over here actually, we can say then that the shape and volume of a solid has a very defined shape. It is a crystal, it is a cube, right? And it also has a very defined volume in cubic centimeters, you could say. So it has a very defined shape, and the amount of space that shape takes up is very defined as well. It's a measurable, defined volume. That is a solid. But what we can do is we can start to add some energy. If we go from low energy into kind of medium energy, we create a liquid. And as we go from a liquid, you can see now that, well, they're kind of looks like a liquid. They're kind of down at the bottom here a little bit. So you can draw them in here. They're kind of like moving around a little bit. They're kind of moving at the bottom of the container, sloshing left and right, kind of like a liquid would. In this case, they're packed more loosely, right? They're not packed together super tightly. They're packed a little bit more loosely. They're kind of loose around there. And because they're a little bit more loose, they can move in two different ways, right? They can move like this. They do move around each other. If we look over here, they're moving around each other, up and down and left and right. They're kind of moving around each other, but in general, they don't leave the group. Now, there's a little star next to that because, wait a minute, one or two did seem to leave the group. We'll come back to those in a little bit. But in general, in a liquid, the particles don't leave the group. They stay in their group. Because of this nature of the particles of a liquid, there's no defined shape. It kind of fills whatever glass it's holding, whatever material it's in, right? Liquids kind of fill whatever shape it goes into. There's no defined shape, but there is indeed a defined volume, right? That the volume of that liquid is defined. And that is something that makes a liquid a liquid. No defined shape, but still has a defined volume, amount of space it takes up. All right, we're almost into the next level. We add more energy. We are now at a high energy. We've made it to the state of gas or vapor. You go to the gas state, they are moving all over the place. They're flying all around here. How are they moving? Well, they are just moving. They're very spread out. They are super spread out, flying all around. You can draw them in here. And because of that, they do move around each other and they do leave the group. Look at that. They are leaving the group. They're just flying all around. That's the particles of a gas, high energy, moving all around. Because of that, there is no defined shape and there is no defined volume. They take sort of the shape of their container, and even the volume is hard to measure. It's hard to figure out how much space is that gas taking up. Well, it can be compressible, and we can see that in there. They go from low to medium to high, depending if you're adding energy and removing energy, which leads us into the last note page for today. There. The last note page today is about the changes of state. And as I said, changes of state occur when you either add energy, and if you have two colors, it could actually help with this. Red for adding energy, or maybe there's a change of state where energy is removed, if you remove energy. We'll look at the added energy ones. We'll use the red arrow to add energy. Say we have a solid and we add some energy, we heat it up, and the solid becomes liquid. We know what that is. It's melting. I'm melting, right? The solid becomes a liquid. That is the change of state known as melting. We talked earlier about the melting point, a very specific temperature at which that happens. Now we have a liquid and we add some more energy. The liquid gets warmer and warmer until it starts to not boil, almost, it vaporizes. Vaporization is another change of state when you add energy to a liquid. Now, vaporization is technically the word because it's becoming a vapor is actually a better word. We can use the word gas, but vapor is a more scientific word for that. And vaporization comes in two ways. One is boiling. If you add heat to water, it'll start to boil, changing state from a liquid to a vapor. But you can also have gas go from a liquid to a gas by evaporation. And evaporation is when those particles move just at the surface. That's why the liquid, if you have here a liquid, it's not boiling. Every once in a while, let's see here, maybe once in a while, one of these top particles, come on, will eventually, there's one, make it away, right? And that's evaporation. Now a few are making it away, all right? The slow removal of particles into a gas at the surface is why puddles will evaporate. The water on the top slowly becomes a gas. That's evaporation. The third one here, down at the bottom, is when a solid goes right to a gas. It skips the liquid stage. And this is called sublimation. Sublimation. A solid can sublimate when it goes from a solid right to a gas. Dry ice, which is actually frozen solid carbon dioxide, it's solid CO2. When it sublimates, that frozen CO2 goes from a solid dry ice right to a gas. And it's super cold. To get dry ice, it's very, very cold. And so that's why it sublimates at room temperature, and you can see it sublimate when it's cold like that. Lastly, there's two other ones to talk about. This is when we're removing energy. We're cooling things down. If you have a gas and you cool it down and the particles go from the gas state to a liquid, it's condensation. Condensation is how the clouds form. Condensation that you can see your breath on a cold day. The water vapor in your lungs, nice and warm, but then you breathe out, and that water vapor as a gas gets cooled down and it condenses to make these little droplets of mist that you see as your breath. That's condensation. If you bring a cold drink out on a humid day, the air, the water molecules in the air, will condense into little droplets on the side of your water glass because it's so cold. That's condensation. And the last one I know, you have a liquid, you cool it until it becomes a solid, and that is good old freezing, right? Freezing is when you go from a liquid state, it's a liquid, and you cool it down, and it goes to a solid. That is freezing. Know this page as well. I'd also put a star next to this page. All of these pages, especially this page and this page, are really important. So make sure you can describe them, describe the different states of matter in terms of the particle movement, and describe the 5 major changes of state in terms of energy movement. All right. I'm sure you have questions. Ask them away, and I will help you out there. All right. And we'll go over these the next class. Bye.